Hi, this is Maggie. In this video we're going to talk about surface transparency. We've worked with surface objects since the first chapter when we wrote our Hello World program. This is listing 8.4 where we can review some of the basics of using a surface before we talk about transparency options. Surface is the type of object in Pygame that you use for visual information. You can think of it as a blank canvas, and you can create as many of these as you need. We use a surface to draw on or to display drawings. We load files stored using a graphics format to surface objects such as JPEGs and PNGs. And we can layer surface objects on top of each other to construct a drawing, similar to how animations are created when drawn on cells. The most important surface for a Pygame program is the surface created by pygame.display.setMode, because this surface represents the Pygame window. We need the Pygame window in order to process events and obviously to display the program's state to the user. So somewhere before we begin processing events, at the point in our program when we're setting up our assets, we call pygame.display.setMode with the size of the game window. And we store the result of that call in a surface object that, throughout the book, we refer to as screen. We then draw to the screen, generally by blitting other surfaces to it. We sometimes have a surface called background, which is the background image for our program. And then we have other images that we blit at various locations over the background. In this program, we blit the background and some star images to the screen. All of this blitting takes place in memory. Finally, when the drawing is complete, we send the pygame.display.flip message, which displays the screen surface to the user. Now on to transparency. There are three types of transparency that Pygame supports. They are color key transparency, surface alpha transparency, and pixel alpha transparency. We will talk about them one at a time. A surface object is a rectangle, which means that when we blit it to another surface, if we don't use any kind of transparency, the whole rectangle is copied. This can be problematic when layering, or if we simply want our image to be a shape other than a rectangle. When I run listing 8.4, the first star in the upper left is drawn without any transparency. We can see a white rectangle around the star obscuring the background. In the code, we simply blit the star. The first kind of transparency is color key transparency, in which we select one color in the image to be transparent. When Pygame blits an image with a color key set, it blits all pixels except pixels that have been designated transparent by the color key. Here is the star image. I've opened it in some drawing software. The star is red, and in this case it's pure red, 25500, and all other pixels are white, or 255, 255, 255. You can see the color when I mouse over the pixels with the eyedropper tool over in this info window. Within Pygame, we can send the set color key message to the star surface. We pass an argument, which is a color tuple, representing the color that should be transparent. So we pass 255, 255, 255. We then blit the star again to a different location. When we run the program, this is the top middle star. None of the white pixels were copied because those are the color we designated as transparent using set color key. Now you have to be careful with a color key. If one pixel is just one value off, for example, if one pixel is 255, 255, 254, then it will be blitted. And if I have a white background and there is some white within my drawing that I don't want to be transparent, then I can't set white as the color key. I will have to change the color of the background, change the white within the drawing, or choose a different transparency method. So let's talk about another type of transparency. In pixel alpha transparency, the transparency information is embedded in the image in the form of another channel. For each pixel, there are R, G, and B channels. In addition to that, some image formats support an alpha channel, which is the transparency of each pixel. Ping is a format that supports alpha transparency. Here is the alpha_star.ping image. And when I mouse over the pixels with the eyedropper tool, you can see that all of the pixels have a color that are red, 25500, but they have different opacity values. Once I move beyond the star into the corners of the drawing, there is an opacity of 0. But the star itself is fuzzy, so out at the edges of the star, I have low opacity values, and in the middle, I have an opacity of 100%. In listing 8.4, when we load in the alpha_star.ping image, we then send it the convert alpha message rather than the convert message as with other images. The convert alpha message converts it to a format that will facilitate blitting to the screen, but that will preserve the alpha channel. When we then blit this image, which is the final image blitted in the code, Pygame mixes the color of the pixels in the star with the colors of the background pixels according to the transparency of the star. You can see the result, which is this bottom star, when we run the program, looks fuzzy. This form of transparency has more information than the others because you can set a transparency for every pixel in the image. The final type of transparency is surface alpha transparency, which allows you to set the transparency for an entire image. So this is similar to pixel alpha transparency in that the pixel colors of the image are mixed with the pixel colors of the background. However, there is only one transparency value for the entire image. So you can have an image that is fully opaque, or you can have an image that is consistently faded by some amount. To set the surface alpha transparency, you send the set alpha message to the image with a value between 0 for completely transparent and 255 for completely opaque. Here in the code we send the set alpha message with an opacity of 150, and we can see in the execution that this results in a star that we can see pretty clearly, but we can see the background through it. Note that the color key is set to none in the program before we blit the star with the surface alpha set, but you can combine the color key and the surface alpha. If we had left the color key at 255, 255, 255 before blitting, then the white pixels would not have been blitted at all, but the red pixels would have some transparency. We cannot combine a color key with pixel alpha transparency, and we cannot combine surface alpha transparency with pixel alpha transparency. So in other words, if you've embedded transparency information in an alpha channel of the image, then you can't apply other forms of transparency. But you can combine the two programmatic types of transparency in Pygame, the color key and surface alpha transparency. So those are the three types of transparency you can use in Pygame, and I'll bet you can imagine applications for these types of transparency. Experiment with them some and get comfortable with how they work before you move on. Have fun.